Hi everyone, welcome to the channel. We're going to be solving question 13 from the 4th chapter of the Hibbeler textbook, and we have this 20 Newton horizontal force that is acting on the handle of the socket wrench, and we need to determine the moment of this force about point B, and after that we have to specify the coordinate direction angles of alpha, beta, gamma of the moment axis. So basically, we are trying to find the moment of the 20 Newton force. And if we look at it, we'll see that the 20 Newton force is in XY plane. So we can dissolve it into two components of X and Y. And we know this angle is 60 degrees. So if we want to find the Y component, it will be 20 cosine of 60 degrees. And the X component would be 20 sine of 60. So this will be the sine because it's the opposite for this side, and the other one is the adjacent to the 60 degrees, so we'll have cosine of 60 degrees. So what we are trying to do in here is to find the moment about point B. Since the moment is a vector, we need the cross product of R and F, so we need R and F both in vector form. So let's figure out what's our R first. So our R in here would be the position vector, or any line that connects our point that we are trying to find a moment about, which is B, to the line of action of the force. So basically, R can be each of these. But since we can find the coordinates of A pretty easy, we're going to call our R this vector. We can show it either RBA or RA with respect to B. Both work. So let's find RBA, and if we look at it, we'll see that we are moving along the y-axis. So we're not. So if you want to find the unit vector, we can see that we are moving this much along the x-axis, which is 10 millimeters. So we are going along negative x-axis. So we have a negative sign in here, 10 millimeter. We can divide that by 1,000 in order to get it in meters. So 10 divided by 1,000, 0.01 meter. That's going to be our I. And for y, moving from B to A, we can see that we are moving minus 200 millimeter along positive y-axis. So we have plus 200, again, divided by 1,000 in order to get it in meter. So 200 divided by 1,000, 0.2 meter. J, and as I mentioned, we are in the XY plane, so no Z component. Now that we have R, we just have to figure out the B, and we should be good to go. So RBA, let's find our F. So as I mentioned, the F acts on XY plane, and we already found the two components for each. So we figured that the X component is 20 sine of 60 degrees, and that component acts along positive x-axis, so positive, and we also have 20 cosine of 60, which as we can see is to the left, so minus 20 cosine of 60 degrees, and that's going to be our J. So let's calculate these two, and after that we can find our determinant in order to find the moment. So 20 sine of 60, that's going to be 17.32 I, and we know cosine of 60 is 0.5, so 20 divided by 2 minus 10 J, and we know that the unit is Newton. So now we can go to our determinant. So we are trying to find the moment about point B. We have our determinant I, J, K. The second row is our position vector, so minus 0.01, 0.2, and we don't have any K component. And for F, we have 17.32 minus 10 and 0. So let's find the I component of this. If we want to find the I component, we're going to cover the first column. So basically we have these two. We're going to cross multiply each of them. So 0.2 times 0 minus 0 times 10 That's going to give us 0, so nothing for x. And for j, we're going to cover the j column, so we have this. So we're going to cross multiply these two, so 0 times minus 0.01, it's going to be 0 minus 0 times 17.32, that's going to be 0.2, so no j component, we only have k component, so if we cover the k column, we have minus 10 times minus 0.01 minus 0.2 times 17.32, that's going to be our k. So if we calculate this, we're going to get 0.1 minus, so we have 0.1 minus 2 times 17.32. So this is going to give us minus 3.364 K, and the unit that we have, since all the forces that we have are in Newton, and we found R based on meter, so it will be Newton meter. So that was the first part of the question, or finding the moment about. And in the second part of the question, we need to find the coordinate direction angles, alpha, beta, gamma. So we know the unit vector of our moment will be in this format: cosine of alpha I plus cosine of beta j plus cosine of gamma k. So if you want to find the unit vector of our m, it will be the magnitude of m, which is what we found in here. It only has k, divided by, we have the vector form, which is what we have in here, divided by the magnitude, so minus 3.364i over the magnitude is basically 3.364, so it will be minus, actually this is k, so our unit vector in here would be minus 1k. So that means cosine of alpha is 0, cosine of beta is 0, but cosine of gamma is minus 1. And from here, we can figure out that the alpha is 90 degrees, beta is 90 degrees, and for gamma, we have to find cosine inverse of minus 1, which will be 180 degrees. So these are the coordinate angles that we were asked to find. So we need to memorize this formula for unit vector in here, because this is how we find the angles of a vector in 3D with each axis. So this will be, the alpha would be the angle with I. You can call it theta x2, theta y, and theta z. I just wrote it in this way because the question named each angle like that. So each of them are the angle with x, y, z respectively. So yeah, I hope everything was clear. Let me know if you guys have any questions from the 3 textbooks that we're covering in this channel, and I can make a video for that specific problem in the next videos. And you guys take care. I'll see you in the next one.